Hello and welcome to Algebra 2 Academic, Chapter 5, Section 1, Model Inverse and Joint Variation. Today we are going to be working on inverse variation with a review of direct variation. So what's direct variation, you ask? Well, here it is. Direct variation. The wordy way you can look at it is a mathematical relationship between two variables that can be expressed by an equation in which one variable is equal to a constant times the other. If you look below it, we have what we'll call the formula E, way of doing it, y equals kx. Overall, how this really applies in the real world is, in essence, this simply tries to say that as x increases, y increases. As x decreases, y decreases. So, as one goes up, the other goes up. As one comes down, the other goes down. That's why it's called direct. Let's look at the parts we have. First part we have is y. That's our output variable. Remember, we keep talking about the range? Well, there he is. X is our infamous input variable, or our domain. Concepts we should remember. Here's the new one, K, constant of variation. Okay. Those are the three parts. There's not a lot to this. Now, how you'd see this in word problems. Y varies directly to x implies y equals kx. Essentially, that's the breakdown of direct variation. Let's put it to the test and see how it works. Oh, look at that. Behold, we have two problems. Whenever you're solving these types of problems, you want to pay attention because there's usually a double setup. First, it tells me y varies directly as x. Thank you. It says when x is 12, y is 48. We use that first part to find out what our constant of variation is. So let's take a look. So we know it varies directly, so y equals kx. There it is. Plug in what we know. X is 12, y is 48. So y is 48 when x is 12. Okay. So now I would divide both sides by 12. Now if we get our handy-dandy calculators out, we'll find out that k, our constant variation, must be 4. All right, so we rewrite this. Y equals 4x. We now know what our system is. So they want to know is, what is y when x is 5? Well, we just plug it in. Y equals 4 times 5. Therefore, y will be 20. Behold. That was kind of fun. That's pretty much as hard as it's going to get. We're going to get to joint later on, which throws a couple more wrinkles, but this is essentially direct. Let's look at our other example down at the bottom. Again, it says y varies directly as x. When x is 18, y is 90. What is x when y is 5? It's a little different. Again, we start out, write down our equation, y equals kx. Plug in what you know. Solve for k by dividing both sides by 18. K is 5. All right. If you don't see that, grab your calculators. They'll help. So that comes over here. So what is x when y is 5? Well, let's find out. So y is equal to 5 times x. But this time they gave me y, so I plug that in. 5 is equal to 5 times x. I'm solving for x by dividing both sides by 5. X is 1. And that is our answer. The word problems will get a little harder, but the key thing is just pay attention to where each variable goes. You have a y, a k, and an x. Y, k, x. The story problems will tell you which one's which. Set first set solve, plug in the new one to solve for the unknown. That is direct variation. Shouldn't be too challenging now. So, you're probably saying, but you said this was model inverse variation. Well, here it is. But oh no, look at this. It still says direct at top. Because this looks so much alike, we didn't change it. So we'll change it right now. This is going to be inverse variation. It says right there, inverse variation. Here's our wordy definition again. Mathematical relationship between two variables that can be expressed by an equation in which one variable is equal to a constant divided by the other. Ooh, divided. Here's our formula-y version, y equals k over x. Now you see the big or right there. Sometimes, some people, like me, write it this way, xy equals k. So what that would say is, if we did in a wordy version, mathematical relationship between two variables that can be expressed by an equation in which one variable multiplied by another equals a constant. Okay? Maybe not as exciting as we think, but here we go. Here's the explanation. In essence, this simply tries to say that as x increases, y decreases. As x decreases, y increases. So, as one goes down, the other goes up. As one goes up, the other comes down. Hey look, the parts look almost the same. Because in theory they are. And then here, y varies inversely to x. Implies y equals k over x. We'll scroll up a little bit, just like Star Wars. All right, so there we go. Let's take a look at some examples. Well, there they are. Now it says here, y varies inversely as x. When x is 10, y is 4. Now I'm going to use the first version to show you how to do that. So y equals k over x. So plug it in. When x is 10, y is 4. So here we go. 4 equals k over 10. So we're going to multiply both sides of the equation by 10. Oops, getting a little outside the lines there. That won't hurt. 4 times 10 gives me 40. The 10s over here cancel out, so k is 40. So now I know what is y when x is 20. Y equals 40 over x. Y is then 40 over 20, which they asked us for. Sorry. Divide that. Y is 2. Well, there you go. Now, what I'd like to do over here is show you the other formula, how it works. xy equals k. You can use either. So when x is 10, y is 4. Look at that, I got the same answer again. So xy must equal 40. When x is 20, we don't know y, but that's equal to 40. Divide both sides by 20. Y comes out to be 2 yet again. So there you can see both formulas lead to the exact same answer. So let's try this one. Here we have a new one. All right. Y varies inversely as x. When x is 17, y is 6. What is x when y is 4? Okay. Y equals k over x. Let's write it down. 6 equals k over 17. Oops, I forgot to multiply both sides by 17. But I'll write that out right there. So k happens to be equal to, if memory serves me, nope, it doesn't. So we'll get it out. 17 times 6. There it is. 102. All right, so let's look at this. Y is equal to 102 over x. Now I'm saying, what is it when y is 4? 4 equals 102 over x. Multiply both sides by x in this case. 4x equals 102. X is canceled out over there. X is equal to 102 divided by 4, which If you look at my calculator, 102 over 4 gives me 51/2. Still not figuring the fraction, we go ahead and write it on in. Again, let's take a look at that using the other formula. xy equals k. Okay. X is 17, and y is 6, equals k. Well, there we get k is 102. Now, we'll use the formula again. So xy equals 102. X times 4 equals 102. Well, x is then equal to 102 over 4, which is still 51/2. There we go. Well, this concludes our demonstration of inverse and direct variation. We will probably get to joint variation when we get back. So, please enjoy.